Okay, good morning or afternoon. Today, we're going to talk about the chain rule. So today we're going to be talking about the chain rule of derivatives. So before we get into the chain rule of derivatives, I just want to talk about some of our previous rules, how it compares, and how we can notice when to use the chain rule. So here are some previous examples from other classes and other lessons. One of them where I have something like 5x times sine x. Of course, that times sign is invisible. And you know that if we have two functions being multiplied together, I would call this one u and this one v. And if those two things are being multiplied together, we would use the product rule, right? And that product rule, once again, we find that derivative by doing, u prime v plus u times v prime. Okay, now, if we have a fraction, or we're dividing two separate functions, and each one of those functions we can take the derivative of, we would call that u and that v, we can use the quotient rule. And remember the formula there. That formula is going to be y prime is equal to, well, u prime v minus u v prime all over v squared. So we have those two rules, and we've talked about those separately. And if you don't remember those, they're in Google Classroom. Go watch those videos and go get caught up. But the third one that we're going to be talking about today is when I have, this isn't sine times 5x, this is sine of 5x, where that 5x is really indicating what we are taking the sine of. And so this isn't necessarily multiplication, this is actually kind of an inside of that sine function. So this time we actually have kind of like an outside and then something different on the inside, where normally that would just be a regular x. Now we have more going on the inside. And this is where we're going to use what we call the chain rule. And we're going to go ahead and we're going to define what is the chain rule, how do we use it, how do we recognize when to use it, how do I say it in our own words. Let's go check it out. So this is going to be when we have an outside and an inside. Let's go check. So here's our very definition of the chain rule. It is used for when we have a function inside of another function. This would be your notes for the day. Copy these down. And we can see that we have f of g of x. We have some function g of x inside another function, right? So that g of x is on the inside of some other function, which is kind of on the outside of that one. So we would see this and we recognize this. We use the chain rule when there's a function inside of another function. Look for those parentheses. All right, and just make sure that those parentheses aren't used to show multiplication, but those parentheses are used to see if there's anything outside of it, right? Used to show grouping inside something else. Okay, if you see that, that is an indication that we'll be using the chain rule. So here's our formula. Instead of using u and v, we're going to be using f and g. So this is what it looks like. We take the derivative of f, we keep whatever is that g of x the same there, that inside does not change, but we notice how the f turns into f prime. So clearly we'll take the derivative of that outside. Right, so think about that as like the outside prime, but notice how the inside stays the same. And then we multiply times, well, g prime, so that's going to be the inside's derivative. Well, in our own words, this is what I'm going to keep saying. Take the derivative of the outside, keep the inside the same, then take the derivative of the, I said outside there. That's not the outside. Of the inside. Okay. So this is, well, that's a bad oopsie. I think I was using copy and paste too much. So we're going to take the derivative of the outside, boom, f prime, keep the inside, there's a g of x, and then we're going to take the derivative of the inside and just make sure we multiply those things together. So let's take a look at an example. One example where this would happen is with cosine, sine, any of our trig functions. So we're going to find dy dx, the derivative, if y equals cosine 4x minus 6. Cosine of 4x minus 6. So here's our function. Now, once again, we can see that we have a function inside of another function. This isn't cosine times 4x minus 6. It's cosine of 4x minus 6. So those parentheses are not showing multiplication, but something is inside something else. That's why those parentheses are being used. So the first thing that we're going to do is we're going to just mark that up, okay? That 4x minus 6 is clearly the inside function, right? That's our g of x, so to speak. And our outside function is going to be that cosine. Now we could, go ahead and take the derivative of the outside. We could try to put this all together in our head. But what I find to be more helpful is to set up our chart like we used to with outside and inside. And I'm just going to call this like outside prime and inside prime. Now you could use like F and G in those situations, but I just find this to be the clearest representation of work. So our outside is cosine. If we take the derivative of the outside, we can look for 8.11 in our notes and we'd find that's negative sine. And then the inside function, the original inside is 4x minus 6, and the derivative of that is just going to be 4. So now it's just a matter of putting this all together for our derivative, right? Y prime stands for derivative, so does dy dx, which this problem asks us. So now let's just make sure we go, okay, what's our rule? We can look here, but I really think this helps me more than anything. Let's take the derivative of the outside, boom, negative sine. And we're going to keep the inside the same. So whatever was the inside first, we're going to keep that as the inside. And then we're going to multiply, right, that multiplication symbol, times the derivative of inside prime, which is 4. And now, of course, we could rearrange these things, which we so often will see in multiple choice problems, right? That 4, right, we can change the order of multiplication. Think about negative sine as being a -1 sign. We can multiply those two coefficients to give us -4 sine of 4x minus 6. And no, don't do any distributing here, right? That 4x minus 6 is inside of a sine function. Think of that sine as protecting it from any operations there, guarding it against distribution. Okay, so this would be our final answer there. So let's just walk through and let's just make sure that our order is tight here. Take the derivative of the outside. That's where that comes from. Then we keep the inside the same. So whatever that inside function was, we keep it. And then finally, we multiply times the derivative of the inside. So there's my inside, which was 4. So if you can get that order, it's just a matter of rearranging it. One answer is good, one answer is preferred, right? So this would be good. This would be very good. How smiley that person is. There's one example of the chain rule. Now there are other examples, and I want to talk about those now. So instead of using cosine and sine and tangent to find derivatives, there are other types of problems with parentheses where we would have to see and recognize chain rule. So let me just erase our work and let's see what we got. Example 2. Example 2 says, okay, if f of x equals 3x squared minus 1, all raised to the 4th power, find f prime of x. Okay, so this is another example of the chain rule because we see something inside another function, right? This isn't telling us 3x squared minus 1 times 4. And now some people might be inclined to try to distribute that 4 in there with exponents, but you can't do that with exponents. That's not how it works. You really want to get rid of that exponent by multiplication. Here's the work that you'd have to do. You'd have to multiply this times this 4 times. Is that something you'd really want to do? You'd have to use the box method like 3 or 4 different times. Is that something you'd really want to have to multiply out to do this problem? No way. So instead of doing that, we are going to use the chain rule to kind of expedite and be more efficient at taking the derivatives of these things so that we don't have to multiply 4 times to use the power rule. So we see here that we can use the chain rule because I have a definitive inside function. And we have something on the outside here, which is just an exponent. Now you might be thinking, well, how do I take the derivative of just an exponent? Well, the way I'm going to think about that outside function is it doesn't matter what that 4 is being raised to, because I know that if I have a power, I can use the power rule. So if the outside function is 4, all I'm going to do is bring that 4 down and subtract 1 from it, like the power rule, even though I don't care what's on the inside. If it's a happy face, an X, a Y, a Z, a whole bunch of things, it doesn't matter. If the outside is an exponent of 4, use your power rule. Now the inside is going to be that 3x squared minus 1. that might be a little bit easier to see the inside of, right? We can just see, right? That's the inside of parentheses. So taking the derivative, that's going to be 6x to the first minus 0, because that's a constant, so just 6x. And now what we're going to have to do is we're going to have to really pay attention to our order when we put this together. So I'm going to say this as this goes. So we're going to take the derivative of the outside. What is that? That's going to be the 4, the parentheses, 3. Keep the inside. So you might be thinking, well, what goes inside? Surely I can't just have something empty there. We're keeping the derivative of the outside. We're keeping the inside the same. So that's where the 3x squared minus 1 comes from. And then we can take the derivative of the inside, which we said was 6x. And now since this 6x is a single term, one just chunk, we can actually bring that out front and multiply it times that 4. Right, 6 times 4 is 24. Bring that x with it. And the rest is just going to be rewritten. No, I can't distribute because that exponent is protecting it. Technically, if I wanted to distribute here, I'd have to do 3x squared minus 1 3 different times. I'd have to get rid of that exponent first. I have to do the exponent before distributing. So I don't really want to do that. That's not going to make things any better. This is as simplified as it gets. This is going to be my answer. So once again, let me just highlight some things. Derivative of outside. Oops, there we go. Derivative of the outside. That's where that 4, 3, and the parentheses came from. We kept the inside the same. Right, there's that 3x squared minus 1. And then finally, we took the derivative of the inside. Okay, so if you got that, you're in great shape. Of course, reorganizing is great algebra practice, especially if you have multiple choice exams. You might not see your answer presented the way that you have it, right? You might not see your answer presented that way. You might see the answer presented this way. So knowing how to rearrange is important for that reason. Okay, that's the chain rule. Go ahead and do your exit ticket, submit that to Google Classroom. Thank you. Adios.